Two billiard balls undergo an elastic collision as shown in the figure below. Ball 1 is initially traveling along the x-axis with a speed of 19 meters per second, and ball 2 is at rest. After the collision, ball 1 will move away with a speed of 9.5 meters per second at a standard position angle of theta equals 60 degrees. For these questions, assume that the mass of ball 1 equals the mass of ball 2, and we want to find the speed of ball 2 after the collision. So this is a two-dimensional collision problem, and for any collision, we always see that the sum of the initial momentum equals the sum of the final momentum. But since it's two-dimensional, we want to consider this, that we need the vector initial momentum to equal the vector final momentum. Okay, now this implies that the sum of the initial momentum in the x direction will equal the sum of the final momentum in the x direction. And similarly, the sum of the initial momentum in the y direction equals the sum of the final momentum in the y direction. That's what we're going to work with in this problem. So I'll draw the situation here. The balls are going to collide in such a way that they rebound off each other at unusual angles here. And we already know the initial speed of this first ball 1. It's 19 meters per second. We know the final speed of ball 1, 9.5 meters per second. Now they didn't tell us what the masses were. And in fact, the masses won't matter when it comes to the angles and the speeds that these objects rebound with. So I can go ahead and assign just a letter m, or I could even give it something that's easy to work with, like 1 kilogram, and that would be fine. So let's let both balls be 1 kilogram. All right, so since we're going to be working with the momentum in the x direction here, let's find out the initial momentum that ball 1 brings to the situation. All right, so P1 initial in the x direction is going to be its mass times the velocity in the x direction. So that's going to be 1 kilogram times 19 meters per second, 19 kilogram meters per second. Now when it comes to the momentum of ball 2, it had actually started from rest. Since it started from rest, P2IX is just going to be 0. All right, now let's see what we can find out about post-collision. So post-collision, ball 1 is going to have components to its velocity. Let's find out what those components are. Over here, we're going to have 9.5 times the cosine of 60. 4.75 meters per second. And up here we'll have 9.5 times the sine of 60, 8.23 meters per second. Now we want to find out what is P1Fx. That'll be found by multiplying the mass times the V final x. But that's what this is for ball 1. Okay, so it's going to be 4.75 kilogram meters per second. All right, good to know. Now let's check out ball 2. When it comes to ball 2, it's going to have a final component of velocity in the x direction as well. V2 final x. And it'll have a y component as well. But we don't know what it is. We want to find out what it is. So let's use this idea here. We'll set up an equation of momentum. The equation will look like this. P1 initial x plus P2 initial x equals P1 final x plus P2 final x. That's conservation of momentum in the x direction. Now let's plug in the numbers. 19 kilogram meters per second plus 0. This one had the 19 kilogram meters per second. This one had none. We have to conserve the 19 kilogram meters per second. And we put in the 4.75 that the one ball has in the x direction. And we can solve now for the unknown. But keep in mind, we're not exactly finding the velocity just yet. We're finding the momentum in the x direction for that second ball. So we'll subtract. I get 14.25 kilogram meters per second. That's going to be P2Fx. Now let's remember though, that this is going to be the mass times the velocity. And since m was just 1, now we have the horizontal component of ball 2's velocity. Now let's try to find its y component of velocity. See, the momentum in the y direction at the start was nothing. The ball 1 was moving horizontally and ball 2 was at rest, so neither one of them was moving vertically. That has to be conserved post-collision according to this equation here. The sum of the initial momentum in the y direction at the beginning has to equal the sum of the momentum in the y direction at the end. But the sum of the initial momentum was 0. So the sum of the final momentum has to be 0 too. Okay, so let's set up an equation for the y direction. P1 initial in the y direction plus P2 initial in the y direction has to equal P1 final in the y direction plus P2 final in the y direction. According to the picture, we see the initial momentum for both balls is 0 in the y direction. So what is the final momentum of ball 1 in the y direction? Let's calculate that real quick on the side here. I'm going to need the y component of its velocity, which is 8.23 meters per second. And I want to now plug that in here. So we can see now that P2Fy is going to be negative 8.23 kilogram meters per second. Okay, so using these two components of the final velocity for ball 2, we can now construct what the speed of it must be. These are the two things we need. Okay, so to get our final answer, we'll do the square root of V2 Fx squared plus V2 Fy squared. That will be the final speed of ball 2. (16.5 meters per second). Notice we could also use those components to find an angle for ball 2. To do that, we would just say, take the tan inverse of the y over the x. And it's 30 degrees. So now we know that this angle here would be 30 degrees, so a total of 90 between them.